Hello everyone. In my previous video, I have explained what is the service bus and its features and characteristics. That video is for more specifically service bus as a messaging service. But I thought that before even understanding service bus, you should know little bit about why do we need any messaging service or why do they even exist in market. In this video, I'm going to explain all of them in detail and where exactly you might use it in infrastructure of your application. We'll understand the need of any messaging service or messaging broker by understanding the problem that any messaging service solves. Consider an e-commerce system flow with a classic monolithic approach. In a classic setup, all the operations are tightly integrated within single hosted application. This single hosted application will handle all the operation in a sequence of order. For example, when an order is requested in e-commerce system, first the item should be added into the cart, then the order processing has to be initiated in which the orders will be inserted into the database and unique ID to refer that order will be generated. After that, payment should be processed in which this will communicate to the external payment system to get the payment is successful. Once the payment is successful, it should take care of completing the order which is already in draft mode and taking to the next level like generation of invoice and initiating the delivery process. All this process has to happen in a sequence order and one operation will wait for another operation to complete and respond it. In this approach, if any of this process is taking more time or getting failed, that will affect the entire flow. For example, if processing order is taking more time because of the slow database connection, then that will affect the entire flow. The entire flow will get slowed down. So that will affect the entire user experience. Also, this monolithic approach has other problem in terms of scalability. This cannot each component cannot scale individually, and it will take a lot of deployment time, and it has to stick with a particular technology for all the component. So to overcome this, we will go to microservice architecture. In microservice architecture, we'll split our application as a logical unit and will communicate among them. In this way, we did achieve scalability. Each component can scale individually or independently. Each component can scale and it can have its own technology for development also. The deployment time also will be very less. So we did achieve all this, but you can still see the sequential dependency is there. Still, one operation has to wait for another operation to complete and respond it. This is where the messaging broker coming to play a role. We'll put our messaging broker between our main order API and other application components. When UI wanted to process an order that will communicate to order API, then order API will create an order request and it will push it to the message broker. The other application component that is listening on the same message broker will get notified and will process accordingly. In this example, maybe the payment processor and order processor will get notified immediately, then they will start progressing parallelly. The order processor will communicate to database and insert the order detail and it will get the unique ID and it will post back to the message broker. Parallelly, payment processor will communicate to the external payment system. Once the payment is successful, it will post the acknowledgement back to message broker. Once both of them is completed, as main or critical part of the order is completed, the order API will notify the UI saying that the order is in progress and UI can take next order. The UI will be free to take next order. In background, this both order fulfillment system or initiating the delivery process can happen. The UI need not wait both of them to complete to notify the user or taking the next order. In this approach, if any failure happen for any of this process, it can retry as the message will be still in the messaging broker. The message in the message broker will be durable as per our configuration. So these component can retry as many times as per our configuration until it gets succeeded. The another benefit of this approach is load leveling, meaning even if you are getting thousands of order requests parallelly, all those requests will stay in the durable queue. None of these application component will get overloaded because of that. All these components will process one request at a time and only after the completion of the request will take the another request for processing. There is no over utilization of resource for any of these component. All those message will be stay in the durable queue and it can process one by one. This approach brings us to build highly reliable and highly decoupled system with the help of messaging broker. Also, this brings the true asynchronous communication between the application components. Depending on the messaging broker what we choose, that gives different ways to handle failed messages as well. There are multiple messaging brokers available in market such as RabbitMQ, Azure Service Bus, and ZeroMQ, and so on. Each comes with its own benefit, but all of them solves this major problem. That is all I have for this video. Thank you for watching. Please leave your suggestion and thoughts in a comment that will definitely help me to improve the content.